you once, now tell me twice. The way I feel, here's my advice. I told you once, now tell me twice. The way I feel, here's my advice.
Coming from the bottom, moving straight to the top. Coming with the full up for the number one spot. Pushing my rap like a pusher on the block. Holding my ground so the rappers get lost. Coming from the bottom, moving straight to the top. Coming with the full up for the number one spot. Pushing my rap like a pusher on the block. Holding my ground so the rappers get lost. Coming from the bottom, moving straight to the top. Coming with the full up for the number one spot. Pushing my rap like a pusher on the block. Holding my ground so the rappers get lost.
The fall of the smartphone gives any owner a lot of unpleasant emotions, which is why manufacturers of gadgets are actively developing various protective devices in this case. The original device was developed by Philipp Frenzel, a 25-year-old university student. Aachen, Germany, future specialist in the field of mechatronics. He integrated the protective system A case into the smartphone's case, consisting of sensors that capture the moment of free fall and drive two pairs of spring legs. They jump out at the corners of the body and absorb shock on the surface. Currently, Philipp is working with Aachen Peter, representing the University of Economics. Together they are working on a startup that promotes new technology. DARPA agency is developing transformer wheels for the Humvee combat vehicle, which changes its configuration within 2 seconds, turning from ordinary wheels into triangular tracks. The tank stands out among other weapons by the presence of firepower, armor protection and mobility. Over the past 30 years, a powerful technological breakthrough has taken place in tank building, which, alas, has hardly touched the last component. This is mobility. As part of the new program, specialists from the National Center for Engineering and Robotics at Carnegie Mellon University have developed a system of transformer wheels, which in 2 seconds turn from tracks to wheels and vice versa. The demonstration took place in Aberdeen, Maryland, in May 2018. Vehicles equipped with these wheels will have less restrictions associated with the terrain and, accordingly, will have better maneuverability. Another development, DARPA Mike's system reduces shaking inside the car when driving on rough terrain by adjusting the suspension. The next innovation is a 100-kilowatt electric motor, which is housed in a standard 20-inch wheel rim. The engine has 3 gears, an internal liquid-cooled brake and the central tire inflation system. A car equipped with such a system does not need a main engine inside the armored core, as a result of which additional space is freed up. Moreover, when 1 or even 2 engines fail, the car does not lose mobility. Someone suddenly wants to advertise directly on the beach or send a message from a desert island to flying planes in the form of a neat inscription on the sand. Then the development of Ivan Miranda's sand robot is simply irreplaceable for this. As we see from a good example, the robot prints text in the sand using a large linear drive on wheels, which moves slowly from one printed column to another. The text is very similar to the matrix format of the 60s and 70s. The robot prints vertically with the necessary indentation, independently lowers and rises, carefully drawing each letter from which well-visible columns are formed. Perhaps the main problem remains the slow printing speed, which can cause some inconvenience. For example, on the beach where the wind can dispel ready-made letters and words after the first tests of the sand robot, Miranda is confident of success and speed, as he considers it is a business. Remote presence technology can accept quite non-standard formats, which is clearly demonstrated by a novelty called Fusion. This is the brainchild of engineers and designers at the University of Tokyo. 2 types of interface were added to the robot, with mounts in the form of a backpack for interacting with a person, a carrier, and a remote operator. Fusion looks like an iron demon from a fairy tale saddled a man and now controls him. The attachment of robot manipulators to the user's hands has direct and feedback. Manipulators move freely under the control of the user, or they themselves move his hands. In the first embodiment, the fusion does not do any useful work. His servos are low-powered and clumsy, so he can't carry the heaviest bags instead of a man or give him a head massage. Any person equipped with fusion can transfer the movement of their hands to another user with a robot. Imagine that a martial arts teacher, musician or surgeon shows the performance of complex movements with full tactile contact. But being with students in different rooms or even in different countries, or a person after rehabilitation with the help of manipulators relearn to hold the plug in his hand according to the written program. Alas, this is just a prototype, but the technology of telepresence embedded in it is rapidly gaining momentum. Researchers at the Massachusetts Institute of Technology lab published a description of a new computer vision technology. But today it's clear that this is a breakthrough. Such a robot does not need to be taught to recognize images. Scientists abandoned the idea of loading into the robot's memory data about objects that he then tries to see in the surrounding world. Instead, the machine is fundamentally abstracted from its environment. It perceives everything around as three-dimensional models from interconnected points. The robot itself scans the item, builds its model and writes the data to its memory by assigning it a label. He does not care what it really is, but he has already examined it and is ready to find it again. Therefore, he can see similar objects even if they are deployed partially hidden, repainted, broken, and so on. He does not know their properties and does not understand what to do with them and how to use this information, but at this stage it is only a vision system, not a new platform. In fact, you still need to train the robot if we want to entrust him with work. For example, to assemble a table from boards, and not to create boards from already finished steel. However, he will not need to tell where the boards and fixtures are in the workshop. When he sees them one day, he will be able to find the necessary items on his own.